Okay, good morning or good afternoon, depending when you are accessing this. I believe a few people have logged on to have a look at the first one. First one on the thermometer was a little bit fiddly, but some good science in it. I believe Holy Trinity Primary might be accessing some of this, so hello if you're one of those. Today, this activity is a little more simple, really basic stuff that you need for it, and we're going to do something about speed. So all you need for this is a toy car, a tape measure or a ruler. So for my students, that's a ruler, that's that thing that you never remember to bring to class. Some tape and some sort of ramp. So we're using a chopping board. Obviously, check what you're allowed to use and don't tape stuff onto a really important surface. About 50 centimeters of length there is fine, and this is dead simple, but we can layer some detail on it for the older students. So starting off nice and easy, but we can add some detail. So the first thing you're going to need is something under your ramp, so it's lifted up. So we're going to be interested in that height, and if you're doing A levels or GCSE, we're going to be interested in that angle, but we'll come back to that. I'll probably do a second video where we're talking about that angle. So the rest of this, you're just going to measure out a distance from where your ramp touches the desk or bench or whatever surface you're using. You want a reasonably thin ramp because you don't want it to jump or fall or go sideways when it's going down. It needs to be reasonably firm so it doesn't bend when the car's going down it. So something like a chopping board, a thin book might work. You'll be able to have a bit of trial and error. So we've got a tape measure and a ruler. You can use either or. We'll talk about the merits of those, and your car. So we've measured out that distance there is 50 centimeters. We did do 25 to start with. It goes quite quick. Depending on what surface you're using, you might need to adjust it. So 50 centimeters is far enough that you can realistically time it. If you don't have a stopwatch, which most of us don't, you can use your phone. That's not a problem. And I'll talk you through in a minute why we've got that gap. So this is dead simple. The variables we're going to have are the height of the ramp and the time it takes to move there, and that way we're going to work out the speed of the car. And if you are moving on to break time after that, you can just get all your cars, race them down and see who wins. There's nothing on Sky Sports, so you might as well race toy cars. So we've got a marker on here, that's where we're going to start, so it's equal each time. And you can either count the distance down the ramp as well, or just on the flat. Doesn't make a lot of difference, but we just need to make sure it's being timed over the same distance. And these two markers here, I'm wobbling all over the place. These two markers, there's one at the front and there's one there. The reason those are there is that we're measuring from the same place. So we're going to raise the height by moving that chopping board in and out. And we just need to make sure that the front edge is in the same place. And we're going to do all our measurements of the height from here. So if we get a ruler, there is a slight issue with using a ruler for this bit, and that unhelpfully, you'll see the ruler, whoa, there we go. The ruler doesn't start at 0. So when I put it flat, it's not actually measuring from the same place all the time. So if you do happen to have a tape measure, and some bananas in the background, if you happen to have a tape measure, you can place that on the spot. And measuring flat on, you can see that you've got 0 there. So the experiment itself is super simple. You place your car in the starting point, you let it go, and we're going to time it from the black mark on the chopping board, which is rather conveniently placed. Let it go, goes down there, and it goes through the gap. Now we're only going to count results that go through the gap, because if it doesn't go through the gap, then it's gone wonky, and if it goes too wonky, we're not comparing the same distance. So the gap's about 1, 2, 3-ish cars wide. That should be fine, and that allows us to measure them. So we're going to start with a number of heights. So we've drawn out a little table. So you should have some paper or a book to record this in. We're going to draw a table out. So over here we got the height of the ramp, and we got the time it takes to move over that distance, and then we'll talk about how to calculate the speed in a minute. So there are 3 times, because this isn't super accurate, So by getting the average, we'll make that more accurate or precise or reliable or repeatable, depending on which exam board you're talking about, because they keep changing terminology. So height 3, 4, 5, 6, 7 centimeters, and then do your time. If you're doing the average or the mean and you're doing a normal calculator, you're going to need to add those 3 times together, then press equals on the calculator, then divide. It's quite important you do it that way, because otherwise it's not going to do the sums in order. So there's an extension exercise in BODMAS or BIDMAS there, I suppose. So when you've got your times, you can work out your mean, and then you can work out your speed. So speed is distance divided by time. If you're doing this for GCSE or A level, we're probably going to want to convert that into meters, because when we start talking about gravity and the forces behind this, we're going to talk about meters per second. But otherwise, keeps the maths easy if we do 50 as centimeters. So the distance, which we measured as 50 centimeters, is divided by the average time for the height, that's 3, and that gives us 45.9 centimeters per second, or 46. That's the average speed for that entire journey. So on our table, do all the different experiments. I haven't finished all of them, but you get an idea of what's going on. So that then can be put into a graph. Now you might not have any graph paper knocking about. That's okay. If you've got any squared paper, that's useful. We'll probably do another video on graphs actually, because graphs are mega important. So 1 decimal place or no decimal places is fine. I don't think we need to be more accurate than that if we're doing centimeters. And our graph is super smooth edit there, I suspect, because I didn't quite video that right the first time. Anyway, our graph will look something like this. So we've got ramp height on the x-axis along the bottom. That's our independent variable, so that is the one that I chose, if that helps you remember. So I chose the values of the ramp height, so it is independent. They both begin with I. On the y-axis is our speed in centimeters per second, and that is our dependent variable. So that depends on the outcome of the experiment, however you wish to remember that. Important note on the x-axis there is that we need to include 0, 1 and 2, because we want to extend the line, even though we won't necessarily have values for 1 and 2. 40 is missing on the speed because I wrote my words a bit big. Nice equal gaps for equal values, so don't skip numbers even if you don't have a result for them. Obviously mine's a little bit rough and ready, drawn on a whiteboard, not to scale. We'll go over that. So if you're doing Key Stage 3, Key Stage 4, A-level, we'll be looking at how to plot that in more detail. You can pop your results on there. There's only 2 points on it at the moment, so we'll return to that. So hopefully that gives us a little insight into speed, and we can just enjoy playing with toy cars. Stay safe and speak to you soon.